All right, let's dive into something that's happening literally every second you're online, but you probably never ever think about it. We're talking about the TCP three-way handshake. Now, I know, it sounds super technical, but stick with me. By the end of this, you'll see it's really just a simple and honestly kind of elegant conversation that makes the whole internet go round.
So, let's start with the big question, the fundamental problem this whole thing is trying to solve. The internet, at its very core, is a bit of a chaotic, unpredictable place. So how in the world do two computers manage to have a perfectly clear and reliable conversation when the network they're using is, well, anything but?
First off, we've got to appreciate just how messy this network really is. This is not like a clean, direct phone line where you know the other person is right there. It's much, much wilder than that.
Imagine you're trying to send a message by mailing a series of postcards. On the internet, some of those postcards just vanish. They never arrive. Or, just to make things interesting, sometimes the postcard gets copied along the way, and your friend receives it twice. That's the internet for you. No guarantees.
And this is where it gets really weird. A postcard you sent last year could get stuck behind a radiator somewhere in the postal system, and then, out of the blue, show up today in the middle of a completely different conversation. You can see how that would cause some serious confusion, right?
So with all these lost packets, duplicated packets, and zombie packets from old conversations popping up, how did two computers cut through all that noise? How did they make sure they're starting a totally fresh conversation, where they both know they're on the same page from the very beginning?
Well, the answer lies in a really brilliant set of rules, a protocol that was designed specifically for this messy job. So let's meet the hero of our story.
This protocol gives us something called a connection-oriented service. And the idea is actually super simple. Before you start talking, you make sure the other person is on the line and ready to listen. It's like calling someone on the phone. You don't just start talking, right? You wait to hear them say hello. You establish the connection first.
And that protocol is TCP, the Transmission Control Protocol. Its whole purpose in life is to take that messy, unreliable internet and build a safe, orderly, and error-free highway on top of it. You can think of it as the internet's super polite conversation manager.
Okay, so how does TCP actually set up this reliable connection? It uses a beautifully simple three-step process called, you guessed it, the three-way handshake.
The entire dance comes down to these three little messages: SYN, SYNAC, and ACK. You can think of it as a quick back and forth. You there? Yep, I'm here. You there? And got it, let's talk. Let's break down what's really going on.
So, it all starts with one computer. Let's call it sender A. It sends out a special message called a SYN packet. SYN stands for synchronize. This is basically A saying, hey, computer B, I'd like to open a connection, and to make sure we don't get our messages mixed up, my very first message is going to be number I. Receiver B gets that message and replies with its own special packet, a SYN ACK. This does two things at once. The ACK part says, roger that, I got your request and I'm acknowledging your starting number I. Then the SYN part says, and hey, I want to talk too. My starting number is going to be J. Finally, sender A gets B's reply. It sends one last packet back, a simple ACK. This is A saying, perfect, I got your confirmation and your starting number J. We are totally on the same page. And boom, the connection is established. It's now a reliable, two-way street ready for all your data.
So you might be wondering, why 3 steps? Couldn't they just do it in 2? Well, that third step is actually the secret sauce. It's what stops those old delayed packets from wrecking everything.
Here's the genius of it. Remember our zombie postcard from a year ago? Imagine an old, hey, you there, from computer A suddenly arrives at B. B, not knowing it's old, would reply, yep, I'm here. Now, if it was only a 2-step process, B would think a connection was open. But because of that crucial third step, A gets this unexpected reply and thinks, whoa, I didn't send anything. So it immediately sends a reset message, shutting down that false connection before any confusion can happen. Pretty smart, huh?
So the whole point of this elaborate little dance is to make absolutely sure that both computers agree on where the conversation begins. Those starting numbers, I and J, are the bedrock of the whole thing. They ensure that no stray old data can sneak in and mess things up.
So, what does this all actually mean for you, scrolling on your phone or computer?
Well, every single time you click a link, load a web page, send an email, or stream a video, this silent 3-step dance is happening. It happens in milliseconds, totally in the background. It's this constant, foundational process that brings order to the internet's chaos, billions of times a second, all over the world, and we never even notice.
And you know, this elegant little handshake is just one of the many, many invisible rules that make our digital world work. It kind of makes you wonder, doesn't it? What other silent rules and hidden conversations are happening right now under the surface, making all of this possible? It's something to think about. Thanks for tuning in.